Hello and welcome to Patch Math, where today we are going to patch your math knowledge on trig identities. Specifically, we are going to look at simplifying expressions using trig identities. Immediately, I want you to think substitution when we are simplifying trig expressions. And what will you be substituting? Well, your identities, your trig identities. I borrowed this from one of my students, and they were given their trig identities here. I went ahead and pulled some supplementary information. I went ahead and pulled some supplementary information from Purple Math in order to list out all 6 reciprocal identities, so that way there isn't any confusion about what we can substitute in. Now you can get the other 3, recreate them from what's given here, but for the purposes of this video, I wanted you to have all the information possible. If you look here are the other trig identities we'll be using today or maybe using today. Go ahead, pause this video, take those in. You'll notice, looking at number 1, we have cosine of theta times 1 plus tangent squared of theta. Now, originally, I misread this, and I thought it was cosine of 1 plus tangent squared of theta. And I worked myself into a circle, and then I went back and looked at the original problem and saw that this is actually multiplication. That is cosine of theta times cosine of theta times tangent. Times 1 plus tangent squared of theta. Now, if you'll see here, that's going to be our first substitution, because if you're familiar with any of your Pythagorean identities, you're going to see that 1 plus tangent squared of theta equals secant squared. That means we can, by our Pythagorean identity, and most teachers would want you to cite that. So by the Pythagorean identity, we can come in here and substitute secant squared of theta in for 1 plus tangent squared of theta, due to the fact that those are equal to each other. Again, this is multiplication, so cosine of theta times secant squared of theta. And at this point, we can erase that parentheses. Setting those two things side by side would be seen as multiplication. Might want to change this a little bit, though, so there's no confusion of what cosine is being taken of. Now that we have that written out, we know by our reciprocal identities that secant is equal to 1 over cosine. In this case, that means secant squared is also equal to 1 over cosine squared. So, by the reciprocal identity, we know that our cosine is going to remain the same here. So it's cosine of theta. But we are going to substitute for secant squared that is equal to 1 over cosine squared of theta. And now we see we've got something that can cancel. We can make any number a fraction, or anything a fraction, by sticking it over 1. And we can multiply straight across the top and straight across the bottom to find that this is cosine of theta over cosine squared of theta. But one of the cool things here, because we have only multiplication and division as our operations, in PEMDAS, multiplication and division are created equally. So rather than multiplying straight across the top and bottom, we can instead choose to cancel on a diagonal. All right? We can choose to cancel that pair of cosines. And cosine squared of theta is equal to cosine of theta times cosine of theta in that denominator. we will be canceling out one of those cosines. So essentially that square is the only thing that goes away. Now this is a running equals. These are equal to each other. We are simplifying. And we find this is equal to 1 over, because that numerator, this comes to 1 when it cancels. 1 times 1 is 1. 1 times cosine of theta is cosine of theta. And we are almost done. 1 over cosine of theta by the reciprocal of the reciprocal identities. We see that 1 over cosine of theta is equal to secant of theta. And that is our final simplified form for this trig expression. All right, your math knowledge has just been patched over simplifying trig expressions using trig identities. Thank you so much for your time.